Here we're starting on page 6 of the second packet of our Chapter 5 notes. We'll actually be covering pages 6, 7, and 8, and you'll need your graphing calculator for this. If you don't have one at home, then please follow along, watch my steps carefully, and then you'll have access to the graphing calculators we have in the classroom. All right, so what happens when you have a higher degree polynomial equation that's not factorable? Well, we must solve it graphically for real roots only. Sketch the graph, indicate the roots on the graph, and list the roots, which are also known as the zeros. They're the x-coordinates of our x-intercepts. So using the calculator, we'll put the equation in y1, in y2 we'll put 0, look at the graph, and for most of these we'll have to adjust the window to get a good picture of the full graph. And then look at the points of intersection, right, with the second trace, number 5. All right, so our first equation here, we want to find the zeros of this higher degree polynomial equation. So we'll take our calculator, and I apologize for this glare that seems to be on there. Go to y equals, we'll key in 2x to the 4th. Make sure you arrow out of the exponent, plus 3x to the 3rd. Minus 28x squared. Minus 12x plus 80. All right, double check that I keyed it in correctly. Looks okay. And my window might have been adjusted, so let me just, standard window is going to be from -10 to +10. So zoom 6 is the standard window. All right, so we don't have a really good picture of this graph. So we're going to adjust the window, and I have the y min and y max on the side. Now for the x min and max, right, if we look at our scale here, it's going from -6 to +4. So now let's press the window key, and the x min is -6, max 4, arrow down to y min, which is -60, and max is 100. Press graph now, and there we have. So it looks like we have definitely 1, 2, and I think there's actually 2 points of intersection there. If I take out my colored graphing calculator, I think you'll be able to see that better. So let me just show you that, yeah, there's definitely 2 points of intersection on the positive portion of the x-axis. All right. Let's look at the table. Yeah, at an x value of -4, we have a y value of 0. At -2, y value of 0. And at +2, a y value of 0. All right, and we don't have the 4th one, so we'll have to calculate that one. All right, but those values were -4, -2, +2, and then there is a 4th one. And before I actually calculate that, let me go back to graph, and let's just sketch what we have so far. So we're coming down, passing through -4, increasing back upward, and then we come down to +2, right? And what is that 4th x-intercept? Well, we'll do our second trace, number 5. First curve, we just hit enter. Second curve, just hit enter. Now for the guess, second curve, enter. Oh, no second curve, y. Go back to y equals. I forgot to put in 0 in y2. So let's do that again. Second trace, number 5. First curve, enter. Second curve, enter. For the guess, I'm going all the way over to the right. I'm going to get this point right there. And it's okay if I go beyond it. And there it is, 2.50. So that our fourth 0 there is 2.5. So this comes down and then loops back up. All right, not such a nice graph, but it'll do. Our x-intercepts -4, -2, +2, and +2.5. So those are our solutions, our zeros. Our next problem, again, go back to graphing calculator. Y equals, clear that out, and let's key in 8x to the 4th minus 12x to the 3rd minus 22x squared plus 3x plus 5. Press graph. All right, and there we have, but the window has changed, so let's go back to our window. Looks like we have 1, 2, 3 real roots, possibly 4. There may be 2 on the negative portion of the x-axis. Our window, our x min, -3, max 4. And the y min, I'm actually going to change that to -50 instead of -40. So -3 for x min, max 4, y min -50, max 20. Press graph. Yes, again, there's definitely 2 points of intersection here on the negative portion of the x-axis. 1, 2, this looks like this might be 2.5. This might be 1.5. Looks like I think we're going to have to calculate possibly all 3 or 4 of these. Let's just check the table. Oh, there we go. There's 1. X value of -1 has a y value of 0, but that's it. So we know that one of the real roots is -1. All right. Now to get the others, second trace, number 5, first curve enter, second curve enter. Got to get closer to this point here. That's going to be our -1 value. It's this value I want. We don't know what that is. That's -0.5, right? -0.50. Let's see if I turn the light on. No, that makes things worse. Okay, so -0.5. I can't get away from that. Okay, second trace again, number 5. First curve enter, second curve enter. For the guess, I want to get closer to this point. Enter. That's 0.5. And same process again. First curve enter, second curve enter. And let's move the right arrow. This looks like it might be 2.5. Yes, 2.5. So there are 4 real roots. Now I'm going to sketch this graph. All right, so let me mark the zeros. -1, -1/2, 1/2, and 2.5. So let's mark the 4 points first, and now sketch the graph. Next, on page 7, we have a higher degree polynomial equation of degree 5. Let's go to the calculator, clear out y1, and key in 3x to the 5th plus 2x to the 4th minus 35x to the 3rd minus 18x squared plus 72x. Before I hit graph, I'm going to adjust the window. All right, our x values from -5 to 4 and y -100 to 50. All right. Now again, if I don't make the adjustment first, and I'm looking at the standard window, Zoom 6 is standard. Okay. This is what I get. They almost look like straight lines. Well, they're not straight lines. We need to adjust the window so we can get a clearer, better picture of the curve. Window, x min -5, max 4, y min -100, and max 50. And we can see 1, 2, 3, 4, 5 distinct points of intersection. What are they? I'll check the table first. Okay, so -3, 0, -2, 0. So -3, -2, 0, 0. 3, 0, and I believe that's it. So that's 4 of the 5. Let me look at the graph again. Okay, so this is -2, -3, here's 0. We have 1 here, we can't see that. Let me move it up. So this was -2, -3, 0, and there's 1 here between 1 and 2, and then we have 3. All right, so the only one we need to calculate is the one just beyond +1. So second, trace, number 5. First curve, enter. Second curve, enter. And now let's move closer to the point of intersection we're looking for here, right there. That's 1.3 repeating, or 1 1/3. All right, so 1 1/3. Let me list the roots on the line. -3, -2, 0, 1.3 with a bar over it, or 1 1/3, and 3. And now let's sketch our graph. Looks like this. Five distinct roots. Now the next part, we're constructing a graph from the given roots and writing an equation from the roots. Given roots P and Q, an equation with roots P and Q is y equals x minus P times x minus Q. The roots of a function are 4 and 2. What is an equation? Sketch its graph. Right. So our equation is y equals, this is one root, 4, so x minus 4, and the other root, 2, x minus 2. That's all. You can FOIL it if you want, but it's not necessary. Looking at the sketch of the graph, let's plot those two roots, 4 and 2. And we can go to the graphing calculator. Go back to y equals. Let's clear this out and simply put in parentheses x minus 4 and x minus 2. and another parenthesis. And I'll do the zoom 6 for our standard window. There we have our parabola. I see here that it crosses, it looks like it crosses at 0, 8. Now this is a parabola, and what's the lowest point here? Let's first check the table. Yeah, 0, 8, so 2, 4, 6, 8. So 0, 8, and then we have 6, 8. And is there a turning point? Yes. At 3, -1 is our turning point. Alright, so that's good enough. Just use these 5 points to sketch our graph. Here we go. So this would be y equals x minus 4 times x minus 2. Three more problems of this type. The roots of a function are -5, -2, and 1. What is an equation? Sketch its graph. So -5, -2, and 1. So y equals x minus -5 times x minus -2 times x minus 1. Just clean that up inside the parentheses. That'd be x plus 5 times x plus 2 times x minus 1. That's all you do, right? It's just x minus 1 root times x minus the other root. And in this case, we have a third root, so x minus the third root. Now for the graph, go to y equals. Let's put in x plus 5. X plus 2, and x minus 1. And graph. Okay, now again, this is a sketch. So we see that it's coming up. And at 12, comes back around, back down, turning point, and starts increasing again. The third one, the roots of an equation are plus or minus 3, so positive 3, and that was -3. -3 and positive 3. We'll mark our zeros there. What is the equation? It's going to be y equals x minus 3 times x minus -3, which would be y equals x minus 3 times x plus 3. We know that's going to be a parabola. Go to y equals, clear that out. X plus 3 times x minus 3. Looks like that turning point. Let's see if I can find that turning point. Look at the graph, the table. There it is, 0, -9. Right, 0, -9 is the turning point. And there's our graph. And the last one. If the roots are -3, 2, and 0, -3, positive 2, and 0. Our equation would be y equals x minus negative 3 times x minus 2 times x minus 0. Let's clean this up. That would be x plus 3 times x minus 2. X minus 0 is simply x. And it would be more standard to just write the x out in front. Go to the calculator. I'm just going to clear 0 out of there. There we go. All right. X times x plus 3 times x minus 2. It's all there. Again, I apologize for the glare. Graph it. Which is worse. Oh, there we have a nice graph. Again, this is a sketch. Make sure your arrows are going the right way, okay? And this concludes our lesson for tonight.